A faint streak of light appears in the southern sky, unremarked at first, just another point amid billions. But it is not just any streak. It is a visitor from beyond. On July 1st, 2025, the Sky Survey Telescope network known as Asteroid Terrestrial Impact Last Alert System, ATLAS, detected something extraordinary. An object on a path unlike any other previously tracked in our solar system. 3I/Atlas, as it was later designated, bears the 3I prefix, marking it as the third confirmed interstellar object ever seen, after 1I/Oumuamua and 2I/Borisov. It hurtles through space at astonishing speed, tens of kilometers per second, on a hyperbolic trajectory that shows it is not bound by the sun's gravity. It is a messenger from another star system, wandering through our neighborhood for only a brief moment. As scientists plotted its path, the realization dawned. This object might pass through our solar system only once. A cosmic visitor on a one-way journey. The discovery triggered the global asteroid warning community to mobilize. Telescopes across every continent and in space were trained on its motion, its light curve, its composition. Because though the object posed no known threat to Earth, its closest approach still tens of millions of kilometers away. Any interstellar body passing through invites deeper questions. Where did it come from? What is it made of? Could it teach us about worlds we cannot reach? In the silent night, as you looked up at the stars, one of those stars may have sent this rock, and the sky watchers were ready. The path of 3I/Atlas is striking. From a direction near the constellation Sagittarius, coming in fast, from the depths of the Milky Way's plane, the object's trajectory defied expectations. It moved in a retrograde, inclined path, crossing the ecliptic. Its perihelion, the closest approach to the Sun, occurs around late October 2025 at roughly 1.35 to 1.4 astronomical units. Then, it will swing outward again, destined never to return. As it entered the inner solar system, the object began to show activity. Telescopes including the Hubble Space Telescope captured images of a teardrop-shaped coma, dust streaming from its nucleus. Infrared spectroscopy from the James Webb Space Telescope revealed a coma rich in carbon dioxide and other unusual volatiles. Hints that 3I/Atlas originated under very different conditions than typical solar system comets. In the asteroid warning community, this object is a case study in vigilance. It passed through regions difficult to survey, near the sun's glare, from a southern sky direction, faster than typical near-Earth objects. The message: our net must be broader, our instruments more sensitive, our readiness constant. And yet, the journey of 3I/Atlas is not just about detection. It is about what it carries: ancient ice, dust, and perhaps clues to another star's history. It is a rock that crossed the void, now temporarily illuminated by our sun, offering a fleeting window into the unknown. What exactly is 3I/Atlas? Is it simply a comet, an icy fragment ejected from a distant star system? Or is it something stranger? Size estimates vary. Hubble data place its nucleus at perhaps up to 5.6 kilometers, though it could be much smaller due to uncertainties caused by the surrounding coma. Observations show the object is shedding mass, dust and gas flowing from its surface, forming a coma and tail. But the chemical fingerprint is unusual. The CO2 to H2O ratio is astonishingly high, among the highest ever recorded for a comet. Changes in color, polarization measurements, and dust grain behavior suggest 3I/Atlas might represent a previously unseen class of object. one forged in environments alien to our sun. For the asteroid warning networks, these anomalies are a reminder. Not all objects conform to our catalogs of asteroids and comets. Some come from the wilds beyond, and they bring surprises. Whether natural or engineered, artificial or ancient, 3I/Atlas demands attention. The possibility that its course change, its behavior and evolution, holds information about its origin reshapes how we think about interstellar visitors. An object passing through our system is not just seen. It is studied, questioned, and in a sense, listened to. Behind every discovery like 3I/Atlas lies a global web of observation, detection, and analysis. Telescopes like ATLAS, the Zwicky Transient Facility, ZTF, and orbiting assets from NASA and ESA coordinate constantly, scanning the skies, flagging objects, and assessing risk. In this case, the network acted swiftly. Pre-discovery images were dug out from archival data, extending the observation arc back weeks and providing sufficient trajectory confirmation to determine the hyperbolic nature of the object. This rapid response emphasizes what the asteroid warning world has learned. Early detection matters. Even though 3I/Atlas presents no current threat to Earth, its closest approach about $1.80 from Earth, its presence is a lesson in readiness. Beyond detection lies characterization. Instruments across the electromagnetic spectrum are trained on the object: visible light, infrared, ultraviolet, and polarimetry. Each measurement feeds into models that estimate composition, origin, and trajectory evolution. The interplay of international observatories is a testament to human collaboration in planetary defense. As we watch 3I/Atlas move through the solar system, alerts are not just about impact risk, they're about scientific opportunity. This object is a bridge between star systems, a gift of cosmic outreach. The asteroid warning networks don't simply protect us, they connect us. Imagine standing on a silent lunar plain or aboard a deep space vessel gazing upward, knowing that a rock from another star system is passing through your solar neighborhood. It is humbling, exhilarating, a reminder of how small we are and how vast the galaxy is. 3I/Atlas will never return. Its path through our system is fleeting. After perihelion, it will swing outward and vanish into the cosmic dark. Yet in its passage, it leaves a trail of questions and inspiration. For the asteroid warning community, its importance lies not in danger, but in discovery. It reinforces the need for vigilance. It proves that the universe remains full of the unexpected. It asks us, what else is out there? What other visitors, silent and swift, may pass undetected unless our eyes are open? There is beauty in this wanderer's journey, an interstellar object that passed through the domain of our sun, briefly lit by our light, observed by our instruments, recorded in our history. It is a cosmic message in motion, and though we may never catch the full story of its origin, we can still learn about ice, about dust, about the processes that shape all planetary systems. The path of 3I/Atlas invites us to think beyond the boundaries of our solar system, to expand our scope, and to embrace our role as watchers of the skies. The asteroid warning networks are not just guardians. They are explorers. They capture the moment when a star system beyond our own sent an emissary. And in the stillness of space, we listened. Because when the next interstellar visitor arrives, and they will, we will be ready.